Today we are going to be reviewing this, the laws of logarithms, or not actually reviewing, we're actually going to be learning this. And this is also on page 473. So if you open up to that page, you're going to see in there that says laws of logarithms, and they're going to give you a bunch of rules. Okay, so I wrote those rules down, and it will be awesome if you guys actually write those down on your notes, okay? Because those are going to be very, very important for the next couple of problems that we are going to do. So what is this? So we have rule number 1 in here. It says that if I have a logarithm with base b and I have m times n, I could actually break that apart and say log base b m plus, so if I'm multiplying, I would substitute that plus with a minus, or I'm sorry, that multiplication with a plus is equal to that. So as you can see, we were able to break this apart. Okay, then I have this other one, log of b m over n is equal to that right there, log of bm minus log of bn. Let me give you some examples of this, what I mean by this. So if I give you log of 20 or whatever, I could actually rewrite this as log of 10 times 2. Okay, why not? Because 10 times 2 is 20. Then if I use this right here, I could rewrite it as log of 10 plus log of 2. Why would I want to do that? Well, the reason why you might want to do that is because, well, you already know what log of 10 is. There is a 1 right there, so this right here will be 1. And then you have 1 plus log of 10. So there's cases where breaking things apart makes the problem a little bit easier. Okay, same idea with this one right here. You have log of n over n is equal to log of bm minus log of bn. And then this one is the most used rule that we have. It's an extremely important rule. It says that log of b m to the k, okay, I could actually bring this k over here, and yeah, so that is a very awesome rule because we're going to be using that a lot. Believe me, that is the most important rule that we're gonna have. Okay, all right, so all right, let's see if we can use some of those rules and do some examples that we're gonna do. All right, so I'm giving you the rules right there. It says in here, example number 1, express log of 6, so log base 6, as m to this, as in terms of that and that. So what they're asking you here is to expand it. What do you mean by expand it? Well, instead of writing it like this, we're gonna write it like this. Okay, so that is expanded form. So this right here, you know, that's expanded. So we are going to express that in expanded form. Well, first of all, let's use the first rule. So rule number 1. So if I have log of 6 m to the second n to the third, I'm going to use log number 1 to break this apart. So notice that we have m squared times n to the third. So I'm going to break this apart like using that right there. So we have log of 6, and then there's this one right here, m to the second, plus log of n to the third. All right, are we done? Not really, because you have to express it in those terms right there. Log of 6m. We still don't have that yet. So guess what? We could actually apply 2 rules as well. So we're going to apply a second rule here, and we're going to do rule number 3 so that I can move those exponents. You see how this one went over here? Well, we're going to do the same in here. We're going to put those over there. So we're going to do 2 log of 6m plus, we're going to bring this one over here, 3 log of n. And as you can see, we wrote those in those terms. And this right here will be my final answer. Okay, in expanded form. Let's take a look at a second example here. If you need to write this down, just go ahead and pause the video. Alright, example number 2. Let's take a look at this one here. We're going to expand this one. So we have log, oops, I always miss the O for some reason, with base 2, and we have the square root of m over n to the 5th power. Alright, so you're probably wondering, how do I do this one here? Well, it's not too bad. You have to go back to the previous section or the previous unit. We have to remember, how could I rewrite this in exponential form? In exponential form, because right now it's in radical form. So what you could do is, well, rewrite this one in exponential form. It will look like this: m over n to the 5th to the 1/2. You guys remember that? Where this is the 2, and then there is like a 1 right there, so it will be half. And then there's different ways you can approach this, but I'm going to distribute that half so that it looks like this: m over half over, and I gotta multiply that times that, and I have 5 over 2. Now we're gonna use one of the rules that we're going to apply. It's going to be rule number 2. So from there to there, I'm going to apply rule number 2. Now hopefully you wrote down the rules, because that's going to help you a lot. So we have log base 2, I kind of forgot the 2 right there, of m half minus, because that's what we have to do for the rule, log of 2 and 5 2. And then guess what? We are going to apply rule number 3 once again. So I'm going to write those exponents. I'm going to put them on the front there. So here's what I'm going to get. I'm going to get half log of m minus 5 over 2 log of, and I forgot the 2 right there as well, and that's how you write it in expanded form. Okay, using those rules and that we have. Okay, all right, awesome. Let's go ahead and do a couple more examples. All right, in this one here, it's a little bit different. It says express as a single logarithm. So we're going to work backwards now. We're going to use the same rules that you have there, rule 1, rule 2, rule 3. And we are going to, instead of expanding it, we're going to be condensing it, okay, as a single logarithm. All right, so if you have a plus right there, okay, when I see that plus right there, because we have the same log there and the same there, right there, you might be thinking, well, I better use rule 1. But we have to be careful here, because you have to realize that there is a 3 right there, and there is nothing in front of the real, like there is nothing in front there. So we have to be extra careful. The first thing we want to do for this problem is to apply rule number 3 backwards. Well, that means that I'm going to rewrite, I'm going to put this 3, and I'm going to turn that into an exponent. You see, just like that. Now we're able to use rule number 1. Because we have a plus right there, we're going to use rule number 1. So we're going to get log of 10. We're going to grab this p times, remember it's multiplication there, times q to the third. And as you can see, I wrote those down as a single logarithm. Let's take a look at number 4. Same idea with number 4. You actually want to apply rule number 3 first. Okay, so that you have log of 10 p to the 4th minus log of 10 q to the 2nd. And then since you have a minus right there, I'm actually going to use rule number 2 because there is a minus right there. So it's going to be log of 10. I'm going to put this one on top, p to the 4th, over q to the 2nd. And that, guys, will be my final answer. Okay, so hopefully you wrote that down. If you didn't write it down, just go ahead and stop the video and then just write it down. I'll just move on to the next question. All right, let's make it a little bit more difficult. We're going to express those in terms of logarithms. Okay, I'll try to do this a little bit faster now since we kind of have an idea of how to do this now. We have all those 3 rules. We're going to use those to expand this. Well, the first thing I'm going to do is, well, first of all, since we're multiplying there, I'm going to use rule number 1. Okay, so rule number 1 right there. And I'm going to say log of 10. By the way, you don't actually have to write log of 10. You just have to write log because the base of 10 is not necessary when you're just using, oh, I'm just making myself. If you write log, you don't have to write log of 10 because it's assumed already that it's base 10. Okay, that's what I meant to say. Okay, so we have log of 10, a to the 2nd, plus log of the square root of b. Now, you're probably wondering, well, how do I do this square root of b? Well, you can rewrite that. That's something that we learned last semester, or last quarter. Not last quarter, last unit, I'm sorry. You can rewrite that b as b to the half. Remember, there is a 2 right there and a 1 right there. And you can use the definition to rewrite it. That will allow you to use rule number 3 to bring this one and this one up here. So you have 2 log, I'm not even going to put the 10 anymore because it is assumed that the base is 10 right there. And that's just for base 10. And the 2 actually gets over. And then we have half times log of b. And that's how we write our answer. Okay, on this one here, number 6, we're actually dividing. Okay, so let's do that. We're gonna use rule number 2 now. Okay, and then we're gonna have log of 10. It's gonna be a to the 5th minus log of 10 square root of b to the 3rd. Okay, now let's rewrite that. We're going to rewrite that as b to the, remember there is a 2 right there, so it's going to be b to the 3 over 2. And let's bring those exponents up front using rule 3. So we're going to have a 5 up front. And we're going to have log, I'm not even going to write the 10, I'm just going to write that there, minus 3 over 2 log of b. Let's do a couple more examples, guys. If you didn't finish writing this video, just go ahead and pause it and then move on. Okay? All right, let's do a couple more exercises. We're going to rewrite this one as a simple logarithm. So we want to write just one logarithm. So instead of expanding it, we want to condense this. We're going to use all those rules that we have available for us. Well, first of all, let's use rule number 3 to bring those exponents up front here. But on this one, you have to realize something, that it's not that obvious that this right here, you need to rewrite it as half times log of 6n. Why do you want to rewrite it like that? Because that will help you understand that, well, now I have to bring this whole thing right there, and so, well, this right here, I'm going to put it right there. Okay, how do I do that? Well, that's by using rule number 3. Okay, so using rule number 3, I could bring those right there, and I could bring that half up there as well. All right, we're almost there, guys. All we have to do now is use rule. Since I see that minus sign right there, that means I'm going to use rule number 2. Okay, so let's take a look again one more time. Rule number 2. Okay, hopefully you wrote those rules down already. So I'm going to write this one first, m to the third over n to the half. And to me, that will be perfect right there. Okay. All right, so that's already 7 examples that we have done for you. So you understand this pretty well. Let's do a couple more. We're going to express this in terms of, so we're just going to expand this. All right, so let's go ahead and take a look. We have log of 4. We have 8 to the second over that square root of b. I'm just going to rewrite it as well as b to the half, because that's how it's going to work, guys. All right, so I'm going to use rule number, since I'm working with division, I'm going to do rule number 2 now. So I'm going to have log of 4, 8 to the second, minus log of 4 b to the 1/2. And let's go ahead and use rule number 3 now to bring those exponents up front now. So it's going to be 2 log of 4a minus, oops, I forgot to put the half. So that half, I'm going to put it on front. As you can see, I just expanded this. All right, we'll do a couple more examples and then we'll be done. I'll do this one's a little bit faster now. All right, so on this one, you want to bring this ones up front first. So we have log, I'm not even going to write the 10 anymore, it's just going to be log of 5 to the second plus log of, this one's going to be the same. Then since we're adding there, this is going to be log of, well, 5 to the second is 25. So it's going to be 25 times 4. So that would be log of 100. And guess what? What is the log of 100? Remember the definition of a logarithm. If you have log of b, and then you have b to the k, then the answer will be k. Okay? Well, in here you have log of 10, and then you have 10 to the second, then the answer will be 2. Okay, same idea. Connect those two. Okay, use the definitions. All right. Awesome. Let's go ahead and take a look at this one here. I'm gonna bring this one up there, and there is nothing there, so we have log of 3 6 to the second minus log of 3 to the fourth. I'm going to use rule number, let's see, rule number 2 to put those together. Okay, 6 squared, remember that's 36. Okay, and then we have 4. Let's actually divide those. And then we get 9. Well, we have to understand what that's in. That is log of 3 to the second. Then that means that we're going to get 2 as our answer. Okay. Awesome. And let's just do, let's see, 2 more, and then we're done with this video. I know it's getting a little bit longer, but this is going to help us in the long run. All right, same idea with this one, guys. This is going to be log of 4. We're going to use rule number 2. Then we have 40 divided by 5. I'm going to divide that. 40 divided by 5. Okay. It's going to be 8. All right, so let's see if we can simplify this or not. That'll be, if I were to translate this, it would be 4 to the x is equal to 8. But then, yeah, okay, I couldn't do this one. So the answer would just be that. I couldn't simplify it even more, because I can't rewrite 8 using base 4. If it was a 2, that would be even better, but it's not. So let's move on. So that one, that's all we do, guys. All right, how about this one here? We have, we're going to do the same thing. We're subtracting. So it's going to be log of 4. It's going to be 3 over here, and then 48. Let's see if we could simplify that. 48, 3 over 48. Let's see if we could divide it by 3. So you get 1 over, let's see, 48. 48 divided by 3 is 16. Oh, this one is going to be more interesting, because I could rewrite this one as, well, this 16 is the same as 4 squared. So now I'm going to put it on top. It's going to be 4 to the negative 2. Why do I write it like that? Well, notice that you have the same base. This base and this base. So that means that your answer is right there. So right there, negative 2. Okay, that's the reason why I write it like that. All right, guys, so we did 12 examples. You're going to watch another video just going over a little bit more problems. It's going to be a little bit more difficult, but we'll get through this, okay? So I'll see you guys in the next video.